Thanks for attending our session. My name is Eric Ironside, and this is Gregory Christakos here. We're both product engineers with the GeoEvent team. Today we're going to be providing an introduction to GeoEvent Server. GeoEvent Server brings real-time data analytics to the ArcGIS Enterprise platform. So quickly, show of hands, who here has used GeoEvent Server, at least installed it? Okay, that seems to be consistent with UC this year, about 25%. So, all right. So as far as the agenda for the session is, we're going to go through a high-level overview of what the capabilities of GeoEvent brings to the ArcGIS Enterprise. We're going to introduce some of the core concepts in using GeoEvent for real-time data processing. And finally, we've thrown in a demo that will tie it all together for you. So before we dive into the GeoEvent side of things, we're going to take a quick look at what it means to perform analysis in real time by reviewing several of our processors and their capabilities. So we're going to briefly discuss the core capabilities of ArcGIS Server and what it means to the broader ArcGIS Enterprise. So when we talk about real-time data, we generally break real-time data into three different categories. So the first category is on the right-hand side. There are things that happen. So these are things like lightning, accidents. So they have a space and they have a time, but you can't really predict where they're going to be. The second types of real-time data would be things that move. These are the typical ones that we're used to seeing. So vehicles, storms, trains, people, ships, assets of various natures. And then finally, the one on the left here are fixed assets that change over time. So these are going to be things like stream gauges, weather stations, and that sort of thing. They definitely have a location and a measurement at a certain time that we would want to get on a map. Here's a quick scenario that illustrates a basic use case of real-time data. In this construction zone, each vehicle is equipped with a sensor that periodically reports its location and status. Vehicle location is continuously updated on the map, as well as we get a breadcrumb trail of where the vehicle's travel history has been. When a vehicle exits one work zone, we get a notification. And when if it leaves all of the work zones, then we get an incident and a notification saying that the vehicle's not where it's supposed to be. So GeoEvent Server itself is a functional role that brings real-time GIS to the ArcGIS Enterprise. This product provides 5 key capabilities. The first is ingesting high volumes and high velocity data from connected devices, sensors, and the larger Internet of Things landscape. So high volume in this case means lots of data. And then high velocity means that the data is arriving very quickly. So GeoEvent is designed to handle both high volume and high velocity data streams. The second one is providing streaming analytics of that data while in transit to both refine and enrich the data and to identify the patterns of interest on the fly. Next, it introduces a big data storage solution to support the volume of data that we're processing. So this SpatialTemporal big data store can be scaled to support the retention needs of GeoEvent. And fourth, we have extended the visualization capabilities of ArcGIS Enterprise through the stream layers for live feeds, as well as both dynamic aggregation and discrete features through enhanced map services coming out of the SpatialTemporal big data store. And the final one is to be able to disseminate notifications and actuation back to devices in the field and directly impact the environment in which those devices reside. We can send emails and text messages as well as send commands to other systems. So diving into each of these key capabilities a little bit further, the first capability, ingesting data from a variety of data providers. These can be vehicles, airplanes, boats, cars with GPS receivers that are moving around. They can be fixed sensor networks reporting their data via radio or cellular connections. They can be weather sensors reporting temperature, pressure, humidity, public safety, if you're looking for the nearest ambulance or a first responder to an accident. And then also commercial operations tracking smart meters, production systems, or assets. So the first key capability is that we have configurable inputs for almost any type of data that you want to bring into GeoEvent so that all of this data can be ingested into the enterprise. The second key capability is that once the data is ingested into GeoEvent, we can do real-time analytics on the data. There's a couple facets to this. So the first facet of real-time data analytics is filtering. When data events are flowing through the system in high volumes or high velocities, it's typically desirable to be able to focus on just the events that matter. So filtering allows us to focus on specific data events and ignore others. For example, I can configure a filter to allow events with a color of orange and blue to flow through while discarding the other events that are going through the system that are not of interest. Filters in GeoEvent also allow us to test for spatial conditions of the data. These spatial tests are performed against known geometries that are stored in memory called Geofences. In this case, a polygon geofence is being used to test the spatial relationship of the point events flowing through the system. So a filter could have been set up to allow data to pass through only when the event is inside of the geofence polygon. It's also important to note that geofences don't necessarily have to be polygons. It's common to see geofences that are points and lines as well. GeoEvent supports all of the spatial relationships that you expect from a GIS, so we can do tests like disjoint, contains, intersects, equals, etc. In addition to filters, we have processors. Processors allow data events to be manipulated, embellished, and transformed in order to discover patterns, relationships, and conditions within the data. We've got a couple dozen processors that provide key analytical capabilities out of the box. If you're interested in getting more information on these key capabilities, we'll be presenting a GeoEvent Analytics session later today at 4 p.m. Some examples of the processors are listed here. So just to point out a couple of these, the first one, the field calculator, uses functions and field values to calculate new values. So calculations can be done against fields of any of the supported types, including strings, numbers, dates, and even geometries. The Fieldmapper allows you to manipulate the schema of your data as it's going through the system. So you can add, drop, or rename fields. You can change types and that sort of thing. The Fieldmapper is very important to utilize to make sure that your schema matches your outputs when you're sending data to output. So it's important to get used to using Fieldmappers in all of your GeoEvent services. So in the example here, you can see, I'll go back through that real quick. The Fieldmapper is transforming this event on the left into the event on the right. It's changing up some of the names of the fields and changing the types. The buffer creator takes an event's geometry and generates a buffer around that geometry. You can then store the resulting geometry or use it to test if it spatially interacts with other geometries of interest. So the buffer is going to take a distance that you provide. Either it's a fixed distance or a distance that's provided by the event itself. Oops. Sorry about that. I got my clicks wrong. The GeoTagger identifies a spatial relationship between an event's geometry and a set of geofences. So it then tags the event with the name of the geofence that passes the spatial operation. So you can answer questions like, which, if any, zone is my vehicle in? Or are any of my field crew in a risk zone? The next one down, the incident detector allows you to monitor incidents that occur over time. For example, tracking a vehicle from the time it enters a geofence until the time it exits a geofence. If you're trying to track how long drivers are at a facility or visiting a well pad or something like that. The track gap detector looks for gaps in the data and will identify when a data stream has not produced an event within a specified amount of time. So if you're looking to make sure that your avalanche crew is still reporting their position and still moving around, you can use the track gap detector to make sure that they're safe. So these are just a few examples of the processors. Like I said, there's a couple dozen of them, and they're all used for doing the real-time analytics. Once you've analyzed your data, you'll most likely need some place to store it. So the primary output included with GeoEvent will send data to a standard Esri feature service. So it will store data in a traditional or hosted geodatabase as features in a feature class. A second alternative is provided for storing your data, and that is with a SpatialTemporal big data store. This big data store is a component of the ArcGIS data store provided with the Esri Enterprise platform for storing hosted data sets. Data tends to come in at high velocity and or high volume, and so in general, the SpatialTemporal big data store is an order of magnitude faster for storing data than a traditional relational feature service. But even if it doesn't come in all that fast, the data can still stack up over time. So this is where the SpatialTemporal big data store comes into play as well. So for example, if you received a relatively low velocity of 500 events per second, it would take just 1 8-hour shift to accumulate 15 million events. So the SpatialTemporal big data store is going to be a good option for storing these high volumes of data. Key capability number 4 is visualization of the real-time data. So GeoEvent supports all of the standard ArcGIS clients, including web and desktop clients via the traditional feature service interface. However, GeoEvent improves the visualization of high-volume data by providing enhanced map and feature services for data sets stored in the SpatialTemporal big data store. This allows on-the-fly aggregation of data while maintaining exceptional performance. So this animation that I'm going to show you in a second here shows data accumulating in the big data store. And as soon as we reach a configured number of events that have been added to the screen, you see it switches over to an aggregated view of the data using hexagonal bins. The bins are configurable. You can set them to display anything you want about the data. So right now it's displaying the counts of the number of features or events that are inside of that bin. But it could be set up to provide any sort of statistical measure of the events that are inside of there. So if you wanted to display, for example, the average temperature of the measurements inside of the bins, or the average wind speed, you could set it up to do that, or the maximum wind speed. We may not always want to store the data. Sometimes we just want to get it on a map. We don't care whether we have a historical record of that data or that it's just stored in the database. In these cases, we can use a stream service. So the stream service are unique to GeoEvent, and they represent a direct connection between GeoEvent and the client application. A client subscribes to a GeoEvent stream service, and then GeoEvent pushes the data out to the client. So the data doesn't stop in between in a database or anything like that. It's pushed directly out to the clients. The clients are not pulling the data, they're not pulling the data, and they don't have to refresh their screen. As soon as the data shows up, it just pops up on the map. So if you're interested in a deeper dive on visualization, there is a real-time visualization session. I didn't bring the little thing to let us know when the next session of that is, but I think it's tomorrow.
Stream data is totally volatile on the client, right?
Sorry?
The streams are totally volatile on the client.
Correct. The streams are volatile on the client. So when the client starts up, it has no data, and the only thing that shows up on the map is the data that goes through the stream service. Finally, the fifth key capability is dissemination and actuation. So we've already seen that GeoEvent allows you to store data in a geodatabase or visualize it as a stream service. But GeoEvent provides a host of other outputs that can be used to disseminate information back out to the larger environment. For example, if we're interested when a specific asset goes outside of its service zone, we wouldn't want to have to watch the map all day and wait for it to go outside of that zone. We could set up a GeoEvent service to notify us using an email or an SMS text message when that vehicle is outside of its service zone. The email that we would send out, we can use specialized HTML formatting on that so that the event itself can contain, or the message itself can contain information about the event, such as the driver's name, and we can send that to a configurable supervisor email or something like that. So another example of dissemination capabilities of GeoEvent is actuation. GeoEvent is fundamentally restful. So both on the inputs and on the outputs. This means GeoEvent can send data to REST interfaces, allowing GeoEvent to interact and affect other things in the environment or the network. So for example, if you're dealing with an Internet of Things on Amazon or Azure Cloud, you can use GeoEvent to communicate with those devices out on the edge. So as events come into the GeoEvent and are analyzed, we can send out those specific device commands based on our real-time analytics. So given these key capabilities, the GeoEvent Manager is used to bring them all together and create your real-time analytics services. The Manager interface provides a monitor to assess the status of your system, of your GeoEvent system. This view shows the state of all your outputs at the bottom, inputs in the middle, and GeoEvent Services at the top. GeoEvent Services define the flow of messages through the system, from the inputs to the outputs, and it also helps configure the processors and filters that are applied to events as they go through the services. Opening up a single GeoEvent service, you can see they're configured using a service designer similar to Model Builder in ArcGIS Desktop. The key difference here is that rather than working with geoprocessing elements, the service designer defines how data will flow through the system, starting with your inputs in green. Starting with your inputs in green, your filters, your processors, and finally your outputs in blue. Please note that you may have more than one of these elements in your GeoEvent service. Also note that each component is configurable so that it can be tailored to your specific use case. And with that, I'm going to turn it over to Gregory. Yep.
Thanks, Eric. So now that we've kind of taken a look at the key capabilities of GeoEvent and what it means for bringing real-time data into the ArcGIS Enterprise, I'd like to spend some time now actually talking about the components that make this all possible. So naturally, when we are thinking about real-time data and GeoEvent, the first question usually is, how do I get my data into GeoEvent? And we achieve that through the concept of, or the components of using our input connectors, as Eric had shown a second ago. So GeoEvent Server out of the box, when you install it, comes with numerous input connectors, good 25 or so. And I've put a sample of some of these input connectors here. For example, GeoEvent Server can pull your map or feature services within the Enterprise or ArcGIS Online to retrieve that data. This is useful, like for example, if you have users in the field using Collector for ArcGIS and they're updating data, we can use that as an input data source for GeoEvent to bring that data in and perform some sort of analysis on that. Another example is GeoEvent's capable of communicating with like the external world, and by that I mean pulling external web servers for data, whether that's text, JSON, GeoJSON, things of that nature. GeoEvent can also receive data that gets posted to it from other endpoints as well. And additionally, GeoEvent is also capable, as another one of its input connectors, of working within its own environment to maybe read files that are located on the system or within your domain. New at 10.7.1, we are excited to announce, for those of you who are familiar with or using Apache Kafka, there is now the ability to subscribe to Kafka topics to retrieve JSON, text, and GeoJSON. And oftentimes, a lot of questions are in regards to how do I get my data in and out of GeoEvent. So I'd just like to take a second to point out that at 10.7, we reworked our input connector documentation, providing summaries, usage notes, parameters help as well. So please take a look at that if you have questions. But that being said, in addition to the out-of-the-box input connectors, we've also worked with a lot of our partners over the past several years to develop various gallery components that you can then bring into GeoEvent Server. So if you're working with our partners to retrieve the data types that maybe are provided by these examples here, you can bring those input connectors into GeoEvent Day 1, which will let you get started with ingesting that real-time data. And then backed by popular demand, we've also developed as a team our own sample connectors using some popular data providers, such as FlightAware or Verizon Connect. And if none of this is exactly what you're looking for, it is possible to create your own input connectors using an easy-to-use user interface within the GeoEvent Manager. It's very plug and play. And if that doesn't work for you, it is possible to create them from scratch using the GeoEvent SDK, which is a Java-based SDK. So we talked about getting data into GeoEvent, and what are some of those examples for doing that. I'd like to now change gears and take a look at how do we get data out of a GeoEvent and elsewhere. So similarly, we have several out-of-the-box connectors, and these are just a small sample, but like we could pull data from a mapper feature service, we can also use GeoEvent to update or add records to a mapper feature service. Eric earlier mentioned the SpatialTemporal big data store. There are unique feature service and map service types specific to that data store that allow us to do some of the aggregation we saw as well. Additionally, we can send features or records to a stream service to display that using WebSocket technology, which we also discussed. But maybe we don't want to visualize our data in a web map or some sort of client. Maybe we're interested in using GeoEvent to do some sort of messaging. There's a variety of out-of-the-box connectors that do that as well, such as sending a text, an email, an instant message, things of that nature. So that way, as users, we can respond to what's going on in real time. And likewise, we could also write to local files as well, as another example. And again, new at 10.7.1, we have the ability to write to Kafka topics related to Apache Kafka. So if that's something that you're interested in, we could talk a little bit more about that later. And likewise, we've revamped our documentation on our output connectors. So each output connector that you see here and more, they each have their own page with additional help. Additionally, we've also developed gallery components. Similar to our inputs, we have the same thing with our output connectors. So we're able to, using these custom components, bring them into GeoEvent and send data to these various sources here. And likewise, it's possible to configure your own in GeoEvent Manager, or through using the GeoEvent SDK, you can develop those too. So we've talked about getting data in and getting data out. Now we want to kind of discuss the analytic capabilities of GeoEvent. So that, with that being said, we're going to talk about our processors. So there's several out-of-the-box processors, as we kind of saw before. Many of these processors perform geometric change on the data. So a buffer, for example, might take a point and create a buffer around that to show some sort of radius or distance from that point. That's just one example. We have the envelope creator, which creates envelope features out of a cluster of points, so on and so forth. We also have processors that perform attribute-based changes as well. So for example, the GeoTagger is one of these many processors where when we detect that our features, maybe our trucks, for example, have intersected a geofence, we can update that record to include the name of the geofence that that truck was within at that given point in time. And for those of you who have been using GeoEvent and have 10.7, you might have noticed this, but there are 6 new processors at 10.7. These are listed here. Our session later this afternoon, 4 p.m., the analytics session, we go in and demo a lot of these new processors. So if that's something you're interested in seeing, please join us for that. Likewise, a lot of the community, as well as we as a team, we've developed add-on processors that you can import into GeoEvent. These are located on GitHub, just kind of further demonstrating the processing capabilities and the development of that a little bit further. And with this, it is possible to create your own custom processors too using our SDK. I'd like to take some time to talk a little bit now about filters within GeoEvent. Those are very important, as well as Geofences, but we'll go ahead and get started with filters here. So filters are highly configurable components that you can include within your GeoEvent service design. We have attribute-based filters as well as spatial filters. So attribute-based filters allow us to take a look at conditions in our data. So for example, we might want to only know of records where the truck's exceeding a speed of 80 miles an hour. We can filter for that to pass those records through and discard everything else. Likewise, we have spatial filters where we could look at our event records coming in and evaluate that spatial condition against geofences. So maybe when the delivery truck is inside a delivery area, we get a notification. Or maybe we're concerned about when it leaves that area. These are just several of those operators that we see here. And these are highly configurable as well. We can define multiple geofences to filter against as opposed to one at a time, and same goes for events. Lastly, I'd like to talk about geofences within GeoEvent. So as Eric talked about a little bit before, oftentimes we think of geofences as polygons. That's kind of a common use case. However, geofences could also be points and lines. And we'll show a demo of that in just a second here. But within GeoEvent, we have two different types of geofences. We have static geofences and dynamic geofences. So static geofences are those features that don't often change or maybe never change. So an example of that might be some sort of boundary, a city boundary or a county boundary or some sort of service area that might not change that much. So GeoEvent is capable of pulling either map services or feature services to get these geometries or shapes or geofences in order to perform some sort of analysis against those. So it pulls it once. In contrast, we also have dynamic geofences. So maybe our geofences we know are changing. For example, storms, if we're tracking storms, that's something that changes constantly in real time. And so if we're treating that as a geofence to see how that storm is interacting with our assets on the ground, we can set up synchronization rules within GeoEvent to pull that map service or that feature service or that stream service to get that data as it updates. So that way we get a real-time view of these geofences as they change. One thing to point out about geofences is that each geofence is given a unique name as well as a category. So that way we could do more refined filtering. So we might be tracking hurricanes as our geofence category, but each hurricane has a specific name that we can then evaluate against. Maybe we're concerned about our assets as it interacts with one hurricane but not another. So that would be an example of that. So having said that, let's go ahead and take a look at a demo that demonstrates a lot of these capabilities as well as these various components within GeoEvent. So we're going to take a look at a situational awareness demo where we have a field crew on the ground. We're going to be monitoring their location as they move around in the field. This is immensely powerful information in and of itself just to see where our assets are. As these individuals traverse the area which we're treating as geofences, we're going to see their zones update from areas that they cleared versus not cleared. And we're also going to see some notifications visualized as they leave the areas that they're meant to be within. So again, we have our three task group members, and as they move throughout the area that they've been designated to search within, we see the symbology of the zones change on the map. On the top there, we see that one of our task members has left the area, so we can display a notification letting us know where that happened, what time it happened, if we were to look at the attribute information, and so on and so forth. As they continue to traverse through the area, we see that the symbology updates accordingly with areas that they've covered. And this gives us insight into where they've been and where they still need to cover, something that they might not see while on the ground. As they continue to move around here, we'll see additional notifications pop up indicating that they've left the area, and this could be symbolic of either that they left the area on purpose or maybe that their work is done and that's why they had left the area. So having shown that demo, we'll take a look now at the actual service itself that made this possible. And I know there's a lot of various boxes here, but we'll break this down bit by bit. So on the top here, we're taking our our field crew data, and we're passing it to two filters. On the top, we have a filter where we're trying to search for when are they inside any zone. So we can pass the records when they're inside any zone to our GeoTagger processor on the right. Our GeoTagger can then update the record for each individual with what zone that they're in at any given time. So at the end of the day, we have a complete record of what areas that they went to and what areas have they not necessarily have been to. Below, we have a similar filter where we're looking for when they're outside all search zones. And we can then use a field calculator processor to look at and update the information that they had left the area. This information ultimately, though, is getting pushed to a stream service, and that's how we're able to visualize their movement on the ground. The other part of this service involves the use of an incident detector. So we're basically, in this case, looking for when they left the entire search area that they've been tasked with staying within. And we're sending that to two different outputs. On the left, we have our stream service. That's how we're able to visualize that they had left the area and display those little warning symbols in red. Likewise, we have another output to send an email, so that way maybe when they leave that area, we can let somebody know from an operations point of view that they had left. And just to give you an idea of the user interface behind this, here we have our filter properties shown, and simply put, all we're looking at here is when the geometry of those individuals are inside any search zone, we pass the record through. And to give you an idea of what one of the UI boxes look like for our processors, here we have our GeoTagger processor. And while there's kind of a lot of different points of text here, really all we're looking at is to tag the search zone that they're within to the field corresponding to that tracker called zone. So we get an updated record of what zone they were in. For this demo, we also created a second GeoEvent service, and this GeoEvent service is responsible for the updating of those zones. So I mentioned before that Geofences aren't always going to be polygons. They could also be points and lines, and this is an example of that. So in the green, we have our input connector where we're pulling those zones, those grids in real time. And we're using our trackers on the ground, or our field crew members, as point geofences. So in that filter, that yellow diamond there, we can see whenever a zone contains any one of those individuals as a point, we can pass that record to our field calculator, where we then change the status of that zone from a default of not cleared to cleared. Then when we pass that information to our stream service, the web map client can symbolize that accordingly based on that cleared or not cleared status. That's how we get that orange to blue effect. So with that, we're going to go into some summary and resources here. So again, GeoEvent Server is a functional role bringing real-time GIS capabilities to your ArcGIS Enterprise. And this, the 5 key capabilities that we talk about here is ingestion, so the ability to take data from various real-time sources such as sensors, vehicles, devices, and the Internet of Things, bring that data information, bring that data in and perform some sort of analysis on it. Which leads me to the second key capability here is analytics. So we perform analysis on that data and filter for that data to detect patterns or particular observations of interest based on our use case. We also have the ability to store that data in the SpatialTemporal Big Data Store, which is designed to handle high volume, high velocity data. We also have some unique visualization capabilities as well, such as pushing data to stream services. So in our demo here, we weren't actually storing this data in any particular database. We were just visualizing that in real time in our web map. And lastly, we have the ability to actuate. So once we get the data and detect a pattern, we want to be able to act on that in real time. And examples of that include maybe sending an email or sending that information out to some sort of device that can then respond accordingly and change to affect its environment. Here's some resources I'd like to share with you. So the first link there brings you to the GeoEvent Server homepage, where we have the updated documentation that I mentioned before, as well as various installation guides, system requirements, and a wide library of tutorials ranging from introductory topics all the way to more specific topics within GeoEvent. We also invite you all to participate on GeoNet. We as a team are very active in checking GeoNet and seeing what questions are out there, so please feel free to check that out. And after the conference, you should be able to find a video recording of this technical workshop as well as others related to GeoEvent at this link. So you just saw the second session of ArcGIS GeoEvent Server, an introduction. Later today, we'll be giving a presentation on the analytic capabilities in GeoEvent. So we take a deeper dive into the processors specifically. There's also a session at the same time involving ArcGIS and the Internet of Things. So that's kind of more of a conceptual conversation of how can we use ArcGIS and bring in our data from the IoT to do analysis. And then there's additional sessions tomorrow, such as our best practices session, which goes into tips and tricks, the do's and don'ts of GeoEvent, as well as road ahead, so what's coming up next with GeoEvent. We're always looking for feedback, so if you would like to, please download and take a look at the survey app to leave us feedback of this session, how it was useful for you or whatever. But we're always looking to improve, so feel free to take that. And we'll go ahead now with the remaining time we have, open this up to questions and feedback. Yes.
So with the geofences, how dynamic can they be? Because once you have a feature class in place, any edits to that will automatically be fed into the geofence stream, or if they require to be static for the entire. Once you set a geofence, can you change it during the situation?
So the question is, how dynamic can geofences be, essentially? Is that kind of a fair takeaway? So using synchronization rules, basically scheduled polling intervals, we can update geofences potentially every second. So as those features are updating in your map services or feature services that contain your geofences, we can take those changes and act upon that. So it could be down to the second.
Geofences can also be synchronized through stream services, so as fast as the data is going through the stream service is how quickly they'll update. Yep. What was the second one? I'm sorry.
Yeah.
I'm not
familiar
with that
yeah,
one.
Unfortunately, not familiar with the mission server. We'll have to. We could follow up with you about that if you'd like. Any other questions? No? Okay. Well, thank you all for your time. We appreciate it. If you do have any questions, feel free to visit us at the RealTime booth in the expo. We're more than happy to talk about GeoEvent with you. So.